2-methyl propan-1-ol, so prop being 1, 2, 3, with an alcohol on number 1 and a methyl group on number 2, and all these would be hydrogens, can be prepared by reacting to 1-bromo, 2-methyl, so a bromine on number 1 on a propane with a methyl on number 2, all these would be H's, with dilute aqueous sodium hydroxide. Now, the question's asking us about a mechanism. We never put metals in mechanisms, so we can get rid of the sodium and just leave ourselves with the hydroxide. Because this is dilute and aqueous, that's a clue to the mechanism. But let's, given that we've been given the structures, we can work out the mechanism. So we have a CH3 joined to a C with a CH3 and a H, and then a C with 2 H's and a Br. So we're just being very careful to copy out what we thought. Then we've got this OH minus with a lone pair. Now the lone pair attacks the carbon that has the bromine and kicks out the bromine. And so we've ended up with that CH3 hasn't moved, that CH3 at the top hasn't moved, nothing on this carbon has been involved. But here, 2 H's haven't changed, but we've swapped the Br for an OH. So we've done a swapping, so this is a substitution. And because we've donated a lone pair to a delta plus carbon, we've used a nucleophile. So this would be nucleophilic substitution. When 2 centimetres cubed of the 1-bromo 2-methyl propane are reacted, we get 895 milligrams of the propan-1-ol, the alcohol, and we've got the density here of the halogenoalkane. Now, percentage yield, we need to calculate moles to work for percentage yield. So the first thing we're going to need to do is find the mass of the 1-bromo ... So it's 1.26 grams per centimetre cubed, and we've got 2 centimetres cubed, so that would be 2.52 grams. So then if we want to find the moles of it, they've given us the MR. So moles is mass divided by MR. So we type that on our calculator, and if you do that on your calculator, you get 0.0184 moles. Now the equation shows us that the ratio is 1:1, so the theoretical maximum amount of the alcohol is, let's just write 2-methyl ... is the same as the amount we started with, because theoretically we should make the same amount. How much did we actually make? How much is 895 milligrams? So 895 milligrams into grams, divide by the MR on your calculator, 0.0121. So percentage yield is the actual, the amount you really got divided by what you theoretically could have achieved in moles times by 100%. If you bang that onto your calculator, you'll get 65.7%, and that's our percentage yield. Then we move on, the question continues on the next page. So when remember it was propane with a bromine on number 1 and a methyl on number 2, reacts with hot concentrated ethanolic hydroxide rather than dilute aqueous, a different product is formed. It's not to do with the potassium and the sodium swapping, it's to do with the conditions changing. Now, they've given us some space for working. Our marks are actually just for these two parts, name of the product and name of the mechanism. But if we work through the question and think about what we would do if it was hot and ethanolic. So when something is hot and ethanolic rather than warm and aqueous, the hydroxide ion doesn't act as a nucleophile, it acts as a base and goes to the next door neighbour carbon to the one that has the bromine. So this carbon has the bromine, it goes next door here, and it takes a proton from next door, so that next door can use those electrons to create a double bond and help you kick out the bromine that way. So when you end up doing that, you've got a C, where the C made the double bond in the middle there, that C had a CH3 and then it had another CH3. We didn't actually do anything to this bit. Okay, and then this side had 2 H's, and we've made water. The hydroxide went to grab that proton and a bromide ion. Now if we had to name this, we'd start 1, 2, 3, or ideally we should put the functional group on the smallest carbon. So 1, 2, 3 with a methyl group. So it's called methyl attached to a 3-carbon alkene propene. You don't actually need a number in methyl propene because where the methyl would have to be on number 2. That's the only carbon it can be on, otherwise it makes the chain longer. And this mechanism is an elimination. Nothing has been added, we've just removed things.